This is One-on-One.
It was my pleasure to introduce one of our distinguished academics here from NJIT, Dr. Treena Livingston Arinzeh, who is a professor of biomedical engineering at NJIT, and it's good to have you with us.
Thank you.
We were talking before we actually officially got on the air. You were talking about biomedical engineering. First of all, what is the field in layperson's language?
It's a highly interdisciplinary field where you combine medicine and engineering together, and so you're trying to solve major medical problems or conditions using engineering techniques. So these can be anything from developing new therapies using kind of cutting-edge biomaterials. These are materials that are implanted in the body. The latest, greatest medical devices. Things that interface with the brain, that interface with spinal cord, could be new diagnostic tools, new imaging techniques that you see in the hospitals, like these MRI techniques, CAT scans.
Let's do this.
Assume
you're not writing for a peer-reviewed journal for your colleagues, right? But we're communicating to the very intelligent audience on public television, but you want to do it in a way that they understand. Someone with a spinal cord injury, you and your colleagues are researching what?
So we're trying to figure out ways how to rebuild or repair that spinal cord, that injured spinal cord. So those spinal cord injuries are a result from trauma. And once that spinal cord is actually damaged, it does not repair. You're left with a huge scar in that tissue. And so the axons, basically the connections that extend from the brain down into that cord and then actually connect to your limbs to be able to walk around and move, that connection is lost.
So
we're
I hate to do this, but for purpose of understanding and connecting, a Christopher Reeve type injury?
Yeah.
So that's you can't fix that.
That's correct.
Go ahead.
Yeah, so that's full paralysis. So we try to rebuild that nerve tissue and make those connections again. And so we use a combination strategy, this tissue engineering strategy.
Tissue engineering?
Yes.
So what does that mean?
Just that. We try to engineer the tissue to rebuild. And so we are combining these implantable materials and cells. And so the cells could be the stem cells that you hear about. And so those cells can turn into nerve tissue, neurons. And so they can make those reconnections. But we use these materials, that's the engineering aspect, to actually help those cells become neurons. So they provide the right cues to those cells to actually lay down the nerve tissue. And it actually provides a nice surface, kind of a placement holder there to help rebuild the tissue and configure the tissue correctly in the cord.
Doctor,
so
where are we now? I know from talking to some of your colleagues in higher ed in this particular arena, I've noticed that some of us in the media, and I'll include myself, we become very impatient. Hey, where are we now? You know, what's the outcome? When are we going to fix it?
Yeah.
Research is slow.
Research takes time, and there's a level of understanding that still needs to happen from the basic biological side. You know, how do these injuries occur, and what's the impact on the tissue? Because especially the spinal cord, you have this huge scar that's left over, and it's really hard to remove that and make those new connections. And so understanding some of that basic biology, and then these new therapies can really work more effectively.
If I were to say to you, how far away do you think we are from X? You won't do it, will you?
I won't say that, yeah. We are, I mean, we're definitely making progress. I think 10 years ago, we had very little understanding, some understanding, but certainly not the level of understanding that we have now of even how stem cells work.
Right.
So that has progressed tremendously. And now we have these new types of stem cells that are being created, these what I call induced pluripotent stem cells.
What?
Well, yeah. Where people induce pluripotent stem cells, or IPS cells.
They didn't exist when?
They did not exist 5 years ago.
And what is the implication of the fact that they exist today?
The implication is now that a patient, so any patients, you can take a person's skin cell and turn them into these IPS cells, these induced pluripotent stem cells. And what that means is a skin cell can now be a stem cell and has the potential to turn into any cell type of the body. So it has this regenerative ability now can be used to help rebuild tissues in the body. So
How
we
did-
weren't aware of that 5 years ago.
Question, you told me before we got on the air that you got into engineering because a mentor of yours, someone in your world said, hey, you grew up in Cherry Hill?
Yes.
Right outside of Philadelphia.
Yes.
Someone said, hey, you have a proclivity for this, you would be good at this, you should do this.
Yeah, so I had that. I was fortunate to have a great physics teacher in high school who said, you know what, you should consider majoring in engineering. And I looked into it, and in college, that's what I did.
So what do you do now for young men and women, particularly in urban areas, and particularly for women?
Yeah, so I'm involved in 3 mentoring programs. One is through the American Chemical Society. It's called Project Seeds program. So we mentor junior and senior high school students, and these are usually underrepresented minority students from underprivileged backgrounds, usually in the city of Newark. And they come and they work through the summer, and they are involved in all the research projects that we're doing in the lab.
Hands-on?
Hands-on, and they're giving great presentations. They eventually move on to publish the work, and they go on and major in, biomedical engineering and other types of science or engineering, disciplines in college. We're also involved in junior high school women students. They come in and also I give them tours and for a couple of days in our lab and the department on campus, so they get exposed to what biomedical engineering is all about. So those are 2 major ones that
What's that like for you?
we're dealing with. It's a great experience, just being able to give back to these students, show them that, look, there's a lot of interesting work that's being done that has real impact in the field, and you can apply everything that you're learning in school. And look, and there's people, there's students that look like you that are in the labs, and you'll grow up, and you can look like me when you potentially look like me. That's someone who's actually doing this type of
You love what you do.
work. So yeah, definitely love the work. It's rewarding at the end of the day to know that, the research certainly takes a while, and it can be frustrating and not go in the direction that you want it to go. But no, at the end of the day, it does have impact. You are making some strides there and learning what's, going on.
Keep us posted.
Definitely will.
Dr. Treena Livingston Arinzeh,
Thank you very much.
Professor of Biomedical Engineering at NJIT. We appreciate you being with us.
Thank you.
Thank you. Stay with us. We'll be right back right after this. Thank you very much.
One-on-One with Steve Aduabto has been a production of the Caucus Educational Corporation, celebrating 25 years of broadcast excellence. Funding for this edition of One-on-One with Steve Aduabto has been provided by Investors Bank, the Russell Berry Foundation, Fedway Associates, Inc., New Jersey State Nurses Association, PSE&G, committed to improving New Jersey's economy and strengthening its communities. New Jersey Manufacturers Insurance Group, auto insurance, homeowners insurance, and banking under the principle of stewardship. Promotional support provided by the Star Ledger and NJ.com, Everything Jersey, and by NJ Biz, All Business, All New Jersey. Transportation provided by Airbrook Limousine, serving the metropolitan New York, New Jersey area. One-on-One with Steve Aduabto has been produced in partnership with St. Joseph's Healthcare System.